For this section, we move the triangles that we've been working with off of the coordinate plane, and we solve them simply as right triangles. The first thing that we need to do is appropriately label a right triangle. For starters, the right angle is always the largest angle of a triangle. We label it capital C. The hypotenuse, which is opposite, is lowercase c. The two acute angles are A and B, and truthfully it does not matter where they're located. Opposite of angle A is side A, opposite of angle B is side B. When we are taking the trig ratios on a right triangle, we use the acronym SOHCAHTOA. I believe I discussed this in the last lesson, but we'll do it again really quickly. So the sine of angle A is going to be the side opposite of A, which is A, divided by the hypotenuse, which is C. The cosine will be the side adjacent to A. Adjacent means next to, so that would be side B. We never call the hypotenuse the adjacent side. The adjacent side is always the side of the triangle that creates the angle that is not the hypotenuse. So the side adjacent to A is B, and again the hypotenuse is C. And then finally we take the tangent, which is opposite over adjacent. So opposite of angle A is side A. Adjacent to angle A is side B. We can do the same thing for angle B. The sine of B will be the side opposite B, which is lowercase b, divided by the hypotenuse. The cosine of B will be the side adjacent to B over the hypotenuse, and the tangent of B will be the side opposite of B divided by the side adjacent to B. In the last section, we talked about cofunctions, so I just wanted to call your attention to that one more time. Notice that the sine of A and the cosine of B have the same ratio. Because this is a right triangle, A and B are complementary angles, so their cofunctions are equal to each other. And you can hear it when you say sine and cosine, tangent and cotangent, secant and cosecant. When you take the trig function of an angle, the cofunction is that angle's supplement, and they're the same. The next thing that we talk about is angle of elevation and angle of depression. If you look in your textbook on page 575, you'll see a graphic with a truck that's looking up at a helicopter. The helicopter is looking down at the truck. Angle of elevation and angle of depression are mostly used in word problems. What you have to understand is that if you're using the same horizontal line, there can be both an angle of elevation and an angle of depression. So you always start at the horizontal. If your terminal side is above, meaning your eyes are sitting here at X, if you are looking up, that's an angle of elevation. If your horizontal is here and your eyes are looking down, that's an angle of depression. So these are very important concepts when you're working on word problems. There isn't a lot of instruction in this particular section because we're already at the examples, but there will be many, many example problems for you to do in class. The first type of problem will look like this. Solve the right triangle if angle A is 34.6 degrees and side A is 120. The first thing that I always recommend you do is draw the sketch. You know what? I'm not going to put A right there. For this one, I'm going to put A here. And that's really because of the way I drew this. If angle A is 34.6 degrees, angle B has to be its complement. The way I drew this, my smaller angle's here, so angle A is a smaller value than angle B. So I'm going to draw it so that it looks like the picture. This makes this 34.6. It makes B 55.4. I was also given that side A is 120. So this is where you have to remember that side A is opposite angle A at 120. When we're solving this right triangle, it means we need to find all of the missing sides. We already found angle B. That's 55.4 degrees. Now we have to find the missing sides. I am going to tell you now, if you use Pythagorean theorem to find any missing sides, I will mark you down. I am assessing your ability to do trigonometry, not Pythagorean theorem. So with that being said, let's start solving for some sides. Angle A was what was given to us, so I'm only going to use angle A unless I absolutely must use angle B. This is one of the things I stress. Never use a calculated value if you don't have to. If you've made a mistake in your calculation, then everything else will be wrong because of the first mistake. Always use what's given unless you have no other choice. So, I know that the sine of A will be 120 over the hypotenuse. Well, A is 34.6, so I take the sine of 34.6, set that equal to 120 over C. Now all I have to do is solve for C. Remember your algebra. To clear a denominator, you multiply both sides of the equation by your denominator. So that gives you C times the sine of 34.6 is equal to 120. Then, to isolate C, you'll divide both sides by the sine of 34.6. So where I started, sine of 34.6 equals 120 over C, I ended with C is equal to 120 over the sine of 34.6. If you notice, if you have a variable in the denominator, it can switch places with what's on the left-hand side of the equation. This is a shortcut. The algebra behind it is what I showed you here. This you can put into your calculator. When you're entering this into your calculator, make sure that you are in degree mode, and you'll get that side C is 211.326. I always round to 3 decimal places. A quick check, make sure your hypotenuse is larger than the side you were given. To find side B, if I'm given A, I'm not going to use C. C was given to me, or C I had to calculate. Always use what's given. So if I'm using angle A and side A, then I know I have to use the tangent. So the tangent of 34.6 is equal to 120 over B. I'm going to use my same shortcut that I used above and say that B is 120 over the tangent of 34.6. This I will put into my calculator. When I do that, I get that B is 173. It's 9499, so I can say 950. Again, another quick check. Angle B is larger than angle A, so side B must be larger than side A. This is the first word problem that we've got in this class. My advice on word problems is to always, always sketch the picture. So if a sailor sights the bottom and top of a lighthouse that's 20 meters high and stands on the edge of a cliff, we've got two angles of elevation at 35 degrees and 42 degrees. How far is the boat from the cliff? So the first thing that I will do is I'll put in my cliff here and my lighthouse. So my boat, there's the water. My boat is here, and the little guy is standing on top of it. And he's got two angles of elevation, one here and one here. The smaller angle of elevation is 35 degrees. The larger angle is this whole angle at 42 degrees. I was given that this lighthouse is 20 meters, and I'm looking for this distance here, the boat to the cliff. For this problem, I will actually start with the smaller triangle, and I'm going to call the height of the cliff h. So what I'll do is I will take the tangent of 35 degrees, because I know that that's h over d. And what I'll actually do is solve for h, which means I will multiply both sides of this by d. So h is equal to d times the tangent of 35. I can do the same thing with the larger triangle, and if you're not sure where that is, it's this triangle here. I would take the tangent of 42, the side opposite is 20 plus h divided by d, and again I'll move d over to the other side, and what I'll end up with is, those cancel, d times the tangent of 42 is equal to 20 plus h. Well, I know that h is this, so I can substitute that in. From here, it's just a matter of algebraic manipulation, so I will subtract d times the tangent of 35 from both sides. I will factor out this d. Remember, factoring is the opposite of distributing. And now you can see that you're multiplying, so to undo the multiplication, d is simply 20 divided by the difference of tangent of 42 minus the tangent of 35. And I can put this entire thing in my calculator. Make sure that you put parentheses around the entire difference in the denominator, or it will not work. When you do that, you end up with 99. 99.902 meters. Now, something I'm sure you're not used to in mathematics. On a word problem, I require you to write the sentence. So your sentence would be, the boat is 99.902 meters from the cliff. For this example, we're told that we have an isosceles triangle, but we're not told that it's a right triangle. So without a sketch, there is no way you would know how to solve this. The triangle you see is exactly what it should look like, with AB and AC being congruent. Here we're told that side A is 12.4 and side B is 17.6. Because AB and AC are congruent, that means that AB must also be 17.6. We'll drop a perpendicular line from angle A because it will allow us to create a right triangle. The hypotenuse is 17.6. The base is now 6.2. If I'm going to find angle B, which is the first one that I'm going to find, the reason I'm not going after angle A is because it's really only half of the angle. To calculate angle B, I need to recognize that the sides I'm given are the side adjacent and the hypotenuse. That tells me I must use cosine. Here I've got a ratio and I'm looking for an angle. So what I do is I call this untrigging the ratio, or you're going to uncosine this. So angle B is the inverse cosine of the ratio 6.2 over 17.6. When I put this into my calculator, I find that angle B is equal to 69.374 degrees. Because this is isosceles, angle C will also be equal to 69.374 degrees. The reason I know this, side B and side C are congruent, therefore angle B and angle C must also be congruent. To find angle A, we'll take 180 minus our two angles. That gives me a measure for angle A at 41.252 degrees. So when I'm solving this triangle, I need to write out very clearly all the missing sides and angles. I know that side C was 17.6. Angle A is 41.252. Angle B, 69.374. Angle C, 69.374. This is a complete answer for the question.